Pipe threads are manufactured in many forms, but the most common types are straight and tapered. Pipe threads are gauged with the go and no-go process, like standard threads. But tapered pipe threads require an entirely different gauging method, a series of 1 to 3 L checks. In this video, we'll cover how to gauge the 3 types of American tapered pipe threads: NPT, which stands for National Pipe Taper, and NPTF, which stands for National Pipe Taper Fuel, and comes in Class 1 and Class 2 classifications. When assembled tightly, NPT threads leave voids at the root and crest of the threads, which need to be filled with a sealing compound at assembly to avoid spiral leakage. NPTF is also known as American Dry Seal Pipe Thread and is designed to leave no voids and therefore requires no sealant. For all 3 types of tapered thread, the L1 gauge is the first check required. This gauge checks the hand-tight engagement lengths, which typically includes the first 4 to 5 threads. For internal threads, the L1 gauge will be a plug gauge with a notch ground into the side for a reference surface. For external threads, the L1 gauge will be a ring gauge, where the flat surface of the gauge acts as a reference. The labeled side of the gauge faces the end of the thread. The part surface, where the pipe thread starts, is used as the reference for all measurements. Each type of tapered thread requires a different use of the L1 gauge. For NPT threads, there's only one test required. Thread the L1 gauge onto or into the tapered thread until the fit is hand tight. When the gauge stops, the notch on the plug gauge or the flat of the ring gauge should be within plus or minus 1 turn from the entry face of the thread. NPTF Class 1 threads require the same check with one major difference. You need to know the distance from the face of the thread to the reference notch in the plug gauge or the surface of the ring gauge to complete the next check in the series. In our example, the L1 gauge is 1/2 turn below the thread surface, which is 0.036 inches when measured. NPTF Class 2 threads require a third step. You must determine if the thread is at the minimum, basic, or maximum condition. To do this is slightly different for internal threads versus external threads. For external threads, if the surface of the L1 ring gauge is within 1/3 of a turn above or below the thread surface, then the thread is in the basic condition. If the surface of the L1 ring gauge is more than 1/3 of a turn above the thread surface, then the thread is in the maximum condition. If the surface of the L1 gauge is more than 1/3 of a turn lower than the thread face, then the thread is in the minimum condition. For internal threads, the conditions are reversed. If the notch on the L1 plug gauge is above the threaded face more than 1/3 of a turn, then the thread is in the minimum condition. If the notch is more than 1/3 turn below the threaded surface, then the thread is in the maximum condition. In our example, the L1 gauge is 1/2 turn below the thread surface, which puts it in the minimum condition. Both classes of NPTF threads require the use of an L2 gauge for external threads, or an L3 gauge for internal threads. The L2 and L3 gauges check the wrench tight engagement length, which generally check the 5th, 6th, and 7th threads. These gauges look similar to their L1 gauge counterparts, but they're designed to verify the taper of the thread. The L2 and L3 gauges are used in similar manners to the L1 gauge. Thread the gauge into or onto the thread until the fit is hand tight. To pass this test, the surface of the L3 gauge or the notch of the L2 gauge must be within plus or minus 1/2 turn of the L1 position. This is the final check needed for NPTF Class 1 threads. In our example, the L2 gauge lies within the pass region that was determined by the position of the L1 gauge. NPTF Class 2 threads require the 3rd gauge in the series, the 6-step gauge, also known as the crest and root truncation gauge or the crest gauge. This gauge is not threaded, but is a tapered plain gauge with 6 steps ground into it. This gauge is simply inserted into the hole or over the external threads without turning, as there are no threads. The 6 steps are labeled in 3 pairs, giving a high and low limit for each of the 3 conditions to be determined with the L1 gauge: minimum, basic, or maximum. If the thread is in the maximum condition, then the face of the thread should fall between the 2 steps labeled MX and MXT. If the thread is in the basic condition, the face of the thread should fall between the 2 steps labeled B and BT. Finally, if the thread is in the minimum condition, The face of the thread should fall between the two steps labeled MN and MNT. In our example, we determined that the thread was in the minimum condition in our L1 check. And you can see the thread surface lies between the MN and the MNT steps of the 6-step gauge and has passed the test. If you still have questions about gauging your pipe threads, contact one of NuVista's application engineers today for expert assistance and to see how much time and money NuVista systems can save you.
Pipe threads are manufactured in a variety of forms. The main types are straight and tapered pipe threads. Straight pipe threads are gauged with the go and no-go gauging process, just like regular threads. But the tapered pipe threads require an entirely different gauging process, a series of L checks. First, the L1 check. Second, the L2 or L3 check, depending on whether you have external or internal threads. And third, the 6-step check. For this video, we will be focusing on the L1 check, as it is the most common in powered pipe thread verification. To learn more about these checks, visit our post detailing the hand gauging of NPT threads. A link will be available in the description below. The powered L1 check is not materially different than that in hand gauging. The process starts by running a tapered thread gauge into or onto a part's threaded feature to the point of stall. If the part is good, then the gauging flat or notch will be within 1 turn high and 1 turn low relative to the face or end of the part. To achieve this, the thread verification unit has 2 sensors to track the position of the gauge. This will ensure that the gauge has gone far enough, but not too far. There are 2 methods of L1 gauging, depending on the condition of the parts: the single-step or 2-step. For most applications, the single-step process is sufficient. This process consists of running the thread gauge member in only once. Occasionally, the parts are dirty or rough enough to the point where the 2-step process is necessary. The 2-step process works like this. First, the thread gauge member is run in or on to stall at a high torque level for a seating or conditioning cycle. Then the thread gauge member is backed away slightly and then run in or on a second time for the gauging cycle at a torque level that is lower to correspond to what would be expected of hand gauging. Just as with go and no-go thread verification, powered verification of pipe threads adds speed, efficiency, and accuracy to your thread quality control process, while still providing results correlatable to hand gauging. Contact one of our applications engineers today to learn how NuVista systems can improve your thread quality control process.